All right, what is the buoyant force on a 5.45 kilogram iron shot submerged in water? What is the weight of the shot in the air? What is its apparent weight when it's submerged, right? So here's the surface of the water. Here's our iron shot, right? Ultimately, there's going to be a force of gravity downward on it, and we all know that iron sinks in water, so the gravity force is bigger than what the buoyant force, right? All right, so let's see. What is the buoyant force? Oh, okay. So this is tricky because I'm telling you the mass of the iron, right? But since we know the density of the iron and its mass, we can find the volume. So the volume of the iron is equal to the mass divided by the density, right? So 5.45 kilograms divided by 7,800 kilograms per cubic meter. So this will give us our volume. And it'll be tremendously small, right? 5.45. Sorry, I didn't mean to say tremendous. Okay. And this is, scare you there, right? 6.987 times 10 to the minus fourth, and that's cubic meters, right? And remember that the volumes of ordinary objects tend to be really small, but this is like 0.7 of a liter, basically, so that's fairly decent, right? Okay. And so let's see, what is the weight of the shot over here? What is the apparent weight submerged? Okay, so let's figure out the buoyant force. So the buoyant force is the density of the fluid. In this case, it's water, right? So I'm going to do density of the fluid, volume of the fluid displaced, right, times G. So that's going to be 1,000 times, the volume is this, right? This is Archimedes' principle, right? That what the object displaces a volume equal to its own volume of water, right? That was discovered in Eureka, California, by the way. Let's see, 1,000 times the answer I just got times 9.81, and that is that buoyant force is 6.8544 newtons. Okay, so that's our first answer. What is the buoyant force? There it is, right? Okay, what is the weight of the shot in the air? What's its apparent weight submerged? Okay, so the weight of a 5.45 kilograms, I'm just going to do mg, right? So 5.45 times 9.81. All right, this is 3.4645 newtons. So that's this force is 53.4645 newtons, right? This upward force is 6.8544 newtons approximately, right? Okay, so then it says, what is its apparent weight when it's submerged? Well, you know, if you imagine that you had a string or something like that holding onto this thing, right? Okay, the force on that string would just be the difference in these things, right? So the apparent weight is just simply going to be 53.4645 minus 6.8544. That's its apparent weight, right? Is the difference between the force of gravity and the buoyant force. So subtract that guy, and I get 46.6 newtons. All right. Now, masterfully, I've kept this space free here, so I'm going to draw a picture of a tiger here. Look at this tiger. I should draw a timber wolf too, but you know, I just drew a tiger. I'm sorry about that. All right.